Okay, we had a few people that missed out on this basic lesson on measuring. One of the things we looked at in class was making sure when you pick up an instrument, maybe this one would be a better example. This ruler only has one unit labeled on it, so it's a little less confusing. Although if you're familiar with the metric system, as most students were, even the incoming freshmen, they knew right off the bat how to interpret the scale. But first, make sure you know what unit you're measuring. In this case, this ruler is measuring centimeters. The next thing you want to do is don't assume just because you're using the metric system that everything is always divided into 10. We talked in class that, okay, from this zero line on the far left to to the one line is 1 centimeter, and we counted 1, 2, 3, 4, 5, and we noticed that that line was longer. 6, 7, 8, 9, 10 marks. And so we divide that 1 centimeter by 10 individual segments. We figured that each one of these was 1/10, or 0.1 centimeters. And we said for most students that was a review. And a couple other things we talked in class, if you missed this lesson, was it's important you start with your zero line at the edge of the, not the edge of the ruler, okay? If you are using a ruler that starts right on the edge of the plastic or whatever material it is, and you notice that this corner is rounded, and so you're not going to have a definite measuring point, and so you would want to move in. Most of our scientific rulers, they're going to be marked in from the edge of the ruler anyway. We want to make sure that we're measuring straight across, and then this picture, we noticed that there's a shadow there, and we said that in class. Most all the students figured out that, okay, that box is probably, the edge is curved. So there's a couple ways we can have some errors in our measurement based on the object that we're trying to measure a width or length or whatever on. And everyone pretty much knew common sense. Okay, you want to line up your line, your zero line, with the edge of the whatever you're measuring. In this case, if you look really closely, I'll try zooming in here, see what happens. Maybe not. I guess I'm going to have to do it the hard way. It will not let me. Okay, there we go. We zoom in really close here, maybe even a little more. Let's go 400% zoom, 300% is most I'm going to get. Well, there you can kind of see, I apologize if the pointer doesn't show up, but that we're kind of less justified, or we're measuring from the left side of that line. A better technique would probably be to center it on the line, and that way it can be consistent. So you're taking, you start with that line centered on the edge. But again, we also discussed that there's some uncertainty when we, even when we do a very technical technique and try to be as precise as we can. This is all zoomed in at like 300%, and the picture's already zoomed out. I don't know. I think it took like a 10x optical. So this is way larger than real life, and so you can kind of cheat more. But we also said one thing you can do in class, if you're trying to make a really precise scientific measurement, you can use a magnifying glass. So you can kind of get this. There are ways you can make your instrument get a little bit more precision. All right, what else did we talk about if you missed class? We said, okay, that there are certain digits and uncertain digits. So anything that has a gradation mark, so we called these lines that don't have numbers, we call them gradation marks, and we call the ones that have numbers index lines. So it's giving you a number. It's giving you a quantity. So that's telling you that this instrument is measuring centimeters, and this is telling you that that's the first centimeter, that's the second centimeter. Common sense, but not all instruments. Some graduated cylinders we talked about in class, instead of being divided into 10, sometimes they're divided into 5 segments. So anyhow, we did say, okay, certain digits are measured by the marks on the instrument, whatever gradation marks you have. In this case, we could say for certain, that this is 2, and I don't know if I have the ability to write on the screen. Let's go like this. Oh, there we go. New version of Smart Notebook that I'm not too good at. So we can say for sure 2, oops, not 3, 2 centimeters, right? We have the ones place. And then we said, so whatever it's marked in the index lines, that's typically going to be your whole digit place. And we said we broke this up into tenths, so we're going to add a decimal place to go to the tenths place. And now we count, okay, 1, 2, oops. See if I can do this with a line, maybe. Let's draw a line. Let's get some color in there. So I'm going to say, okay, oops, don't want to do that anymore. Undo. We're going to now move that line to count to maybe show up a little better on the screen. So we have 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. And we could argue if it's to the 6th line or not. I'm going to say it's there. It's actually left justified just like our 0 line was over here. So we're consistent where we start. We're measuring from the left of that mark. And we're being really nitpicky, but that's the whole point. We're being ultra geek mode here, okay? So this is way more nitpicky than you'd be if you're just, I don't know, making a gingerbread house or actually even building a house, okay? You're not going to divide your gradation marks more than what they're already on the ruler. This is just a science technique that we're practicing on a ruler, and we'll use it maybe for burettes or graduated cylinders, whatever. So okay, so now we can say this is a 2.1 line, 2.2, 2.3, 2.4. The line that's a little bit longer than its neighbors, we said is usually marks the halfway point, so 2.5. So you can, without counting, you can start counting at the 2.5 mark, right? And this would be 2.6. We have a line, so when I come back up here and I look at my measurement, I'm going to say 2.6. And to be a good student, we're going to throw centimeters in there already. We're going to always put a unit with our measurement. And now we said, okay, looking at this digit here, the 2 is certain. Okay, we can know that this measurement is at least 2 centimeters. And we can also know that it's at least 2.6 centimeters with certainty. And we're going to add an estimate digit, one more decimal place more precise than what our instrument is marked at or graded to. So in this case, if it's exactly on the line, I'm going to call that 2.60. Okay? And we said, okay, well, that's all well and good. This digit on the left is certain. That digit, the middle digit, is certain as well because we have a 0.6 mark or a 6/10ths mark on this ruler. It's right there. And that 0 digit is uncertain because we estimated. There's no 0.00 line or 001 line rather, or 002. There are no lines corresponding to the hundredths decimal place of centimeter on this ruler. So when we make that measurement, that reading, it's going to be an estimate. The bottom line is, if, let's say, your measurement, instead of being right here on the end, let's say it was right there. Okay, so instead of being 2.60, you're going to say, okay, this is about halfway between those two lines. We'll make another line here. Let's do an arrow maybe, and maybe we can see a little bit better what we're talking about. Oops, let's reverse this. I'm not going to reverse it. I'm going to see if I can spin it around here. Pardon the clumsiness of this, but I think we get the point of it. So, that line there was 2.6. We said that line there, 2.7. So it's halfway between, say the edge of that box was halfway between those. We're going to estimate that it's 5/10ths, or let's see, half the way is going to be 5/100ths rather. So we could, our final estimation, our final measurement rather, is going to be 2.65 centimeters, and we said that the first two digits are certain, and that last digit is an estimate. Now, just because it's an estimate doesn't mean um, it's meaningless. So again, we're imagining that my box was smack dab. It ended instead of right here, it ended smack dab in the middle of those two lines. It's generally accurate, this technique. We would find out that, you can kind of just figure visually, plus or minus 0. About 0.3 or 0.2 units more precise, whatever decimal place. And sorry, I can't see this. Is not cooperating with me. I'd rather do it with a pen, but then we're not going to see it. All right. See if I can find a chunk of. I do it that way. So, okay. Plus or minus. 2/10 or 3/10. For you guys, if it's within 3/10, I'm not gonna, or 3 more hundredths in this case, because we have tenths as a certain measurement. So a hundredths place, hundredths of a centimeter, is going to be what's uncertain. But again, looking at the way this ruler is right now, we're going to say that this would be 0.60. And we also said in class that it'd be acceptable. Pretty much every student agreed, and it made sense to them that we could say like a 2.59 would be reasonable, maybe even a 2.58. Again, all centimeters. Oops, 2.58 or 2.61. Cannot type tonight. Or 2.62. Okay, so there's always going to be a little bit of estimation in that last digit, and there's going to be some variance, even if you were the same student measured it a couple times. Let's see how this turns out. Wow, is that 11 minutes?